Hello, so today we're going to cover the laws of indices. These are very important when you're dealing with equations in astrophysics and spacecraft design, for example, where you have to combine terms in equations, and we will show that in a separate video. So for the laws of indices, there are several that we need to learn and be familiar with. And this is really fundamental knowledge. So the first one, number one, is known as the product rule. Not to be confused with the product rule in differentiation, which is a different idea. And so if you have a variable a to the power of m times by a variable a to the power of n, it simply says that this is also equal to a to the power of m plus n. So for example, if we had a term x cubed and we have another term x to the fourth, and they're being multiplied by each other, then this can also be written as x to the 3 plus 4, which of course is equal to x to the 7. So you simply add the powers. Nice and simple. The next one, number 2, is known as the quotient rule. And that's because we're dealing with division. And this simply says that if you have a variable a to the power of m divided by variable a to the power of n, this is equal to a to the m minus n. So again, using an example, if we had x to the power of 6 divided by x to the cubed, this is the same as saying x to the 6 times by x to the minus 3, which is the same as saying x to the 6 minus 3, which of course is x cubed. Nice and simple once again. The next one is known as the power of power law. So we'll call this number 3. The power of, or rule I should say, power of power rule. And it simply says that if you have a variable a to the power of m, we'll put this in brackets, and that itself is to the power of n, then this is the same as saying a to the m times n. So to write an example, if we had x cubed squared, this is the same as saying x to the 3 times 2, which of course is x to the 6. Number 4 is the power of a product rule. And it simply says that if you have a variable a and a variable b, both to the power of n, then that indices applies to both of the variables. So it becomes a to the n times by a to the b. And so again, let's do an example. If I had 4x squared, so 4 is a and x is b in this example, this is the same as saying 4 squared times by x squared, which of course is 16x squared. Next, we have number 5, which we will call the zero exponent rule, because in this example you have a variable a to the 0, where 0 is the exponent. This is always equal to 1. Provided that a is not equal to 0. So if we have an example, 2 to the power of 0, for example, that is 1. If we have 9 to the power of 0, that would be 1. It's always 1, except when a is not equal to 0. Number 6. We will call the negative exponent rule, and this is where you have variable a to the power of minus n. This is the same as saying 1 over a to the n. So if we had variable a to the minus 4, for example, that's the same as saying 1 over x to the 4. And finally, number 7, which we will call the fractional exponent rule. So if you have a variable a to the power of m over n, this is the same as saying the n root of a to the m, which is equal to the n root of a to the power of m. Okay, so where the n is a root among the fractional powers. So for example, if we had 8 to the power of 1/3, that's the same as saying the cube root of 8, which is equal to 2. I'll just do one more example. If we had 16 to 3/4, that's the same as saying the 4th root of 16 all to the power of cubed, which is equal to 2 to the power of 3, which is 8. And that concludes our very brief introduction to indices. And in a separate video we will show how we might use some of these in combining equations in terms. That's it.